So we have this really kind of cool problem. We have an amateur radio operator who's building a radio antenna near his home, and without using his house for bracing. He doesn't want to who wants to really attach a radio antenna to your house? He uses 3 bracing poles to brace the antenna so it doesn't fall over. The poles are inserted in the ground, equidistant from the antenna, located at J, K, and L. And I've located J, K, and L on the coordinate grid just to make life a little easier. What are the coordinates of the antenna? And the antenna is equidistant to J, K, and L. How are we going to do this? Man. Well, when in doubt, let's start connecting points, right? So here we go. Let's connect K and J. Let's connect L and J. Oh, so we have a triangle. Now, how are we going to find one point that is equidistant from all 3 corners? Well, if we found a point that is equidistant from all 3 corners, that would mean we could draw a circle that circumscribes a triangle. Oh, we can find the circumcenter, can't we? Oh, right, excellent, okay. So now we're moving here. So the circumcenter, you'll remember, is found by finding all of the perpendicular bisectors to the triangle and where they intersect. And all 3 perpendicular bisectors will meet in one spot. And where they meet, well, that's the circumcenter. Great. Okay. So how do we find perpendicular bisectors? Well, bisect. Well, that bisecting means we are cutting it in half. So let's find the midpoints. So I'm going to find the midpoint of JK, because I'm just kidding around with this. Just joking. All right, so to find the midpoint, I just find the average of the x's and the average of the y's. Okay, so that means for our x value, we have 4, that's J, plus -3. Okay, that's all right. And we're finding the average. We have 2 points, so we have to divide it by 2. Okay, no big deal there. All right. Oh, that 2 doesn't want to be underneath, does it? All right. So that's going to be our x value. So now we need to find our y value. Yeah, I know. I just duplicated it. Okay. So here we go. Well, let's put in the points for the values for the y. All right, so for our y values, we can have 4. I really do want to have this underlined. 4 plus -1. And that whole thing will be over 2. Because again, we only have two values, right? All right. So, and I'm going to make this start looking like a let's try that again. So we're going to make this look like a coordinate point. Okay, a little bit like a coordinate point. All right, so that will leave us with 3 over 2. All right. And for our y values, we have, oh no, geez. 4 plus -3 is 1. What am I thinking? I was looking at the wrong thing. 4 minus -1 is 3. Geez, having troubles. I just realized Max class starts in like 10 minutes, so I'm trying to hurry. When you hurry, you make mistakes. So we know that our point is going to be at 1/2 comma 3 over 2. So 1/2 over, oh, that's right here. All right, perfect. And so now, well, this slope here is, well, let's figure out the slope. So we're going up 1, 2, 3, 4, 5. So the slope is 5 over 1, 2, 3, 4, 5, 6, 7. And it's positive because it's going up. And the slope of the line that's perpendicular is going to be the opposite reciprocal. So the slope for my perpendicular bisector will be negative 7 over 5. All right, so from this point, down 7, 1, 2, 3, 4, 5, 6, 7 over 5, 1, 2, 3, 4, 5. All right, there. Let's connect the dots. Oh, that's interesting. Look, it intersects that side perfectly. Well, I didn't really enjoy this method so much. So the other way I could do this is I could find the perpendicular bisector. So by using my compass. So open the compass past halfway. I'll work in yellow here. All right. Oh, shoot. Obviously, I didn't make my X big enough over here. Or my arc big enough. There we go. So now I can connect my two intersections of the arcs. Oh, look at that. They intersect right on that point. So this must be my center point. So my center point is, let's see, 1, 2, 3. So that's 3 over. And down 2. So that's where the antenna is located. All right, good deal.